Alright, let's look at the homework 3.6, 3.7, number 11. Alright, so we want to sketch the graph of y equals x plus 9 over x. Right? So x-intercept. Alright, so let's find the x-intercepts. Alright, x-intercept, so if you're looking for x-intercept, then you are setting set y equal to 0. Right, so let's do that. So you have x plus 9 over x is equal to 0. Right, so which means that we want the numerator to be 0. Then you can just subtract 9, so x has to be negative 9. Right, so put that in. Right, so that's going to be negative 9. Alright, y-intercept. Let's find that. Alright, so if you want y-intercept, all you have to do is set x equals 0. Alright, then you notice that actually this function is not defined at 0. So because there's x on the bottom, so you have y of 0 is actually undefined. Right, so which means that there is no y-intercept. Right, so we can answer that. Right, so it's got to be does not exist. Right, then relative max and relative min, so we're going to take the derivative. Right, so we can look at it as, let's see, I'm going to actually rewrite it as this. Right, x divided by x is going to be 1. You have plus 9 over x. Alright, so let's take the derivative. Y prime is going to be equal to, alright, so derivative 1 is 0. And the derivative of 9 over x squared would be, if we rewrite it as 1 plus 9 times x to the negative 1. So derivative is going to be negative 9, right, x to the negative 2, which is negative 9 over x squared. Alright, so you can see that this is actually always, let's see, so this is going to be always negative. Right, which means that it's always decreasing, so there's no relative max or relative min, so it's going to be does not exist, and the relative min does not exist. Right, point of inflection, so we have to take another derivative. Right, so y double prime is going to be, all right, so put negative 2 in front, so that's going to be 18 x to the minus 3. All right, so you can see that this is the same thing as 18 over x cubed. Right, so this guy is never 0 because 18 we cannot make 18 0, so this is never 0. We know that the y double prime at 0, because denominator is 0, is undefined, but 0 is actually not included in the domain because the original function has x on the bottom. So you could not have inflection point at 0 either. So there's no inflection point in this case. So another does not exist. Right, and a horizontal asymptotes and a vertical asymptote, we can find that. All right, if you want the horizontal asymptotes, right? We can use the trick. So on top you have degree 1. On the bottom, degree is 1. So when you have a tie, leading coefficient over leading coefficient. So you can see that the y equals 1 is the horizontal asymptote. So let's go back, and the horizontal asymptote is y equals 1. All right, then next one is vertical asymptotes. Right, vertical asymptote is going to be, you can see that there is no common asymptote. In the original equation or original function, there is no common factor, but the x equals 0 makes the denominator 0. So x equals 0 is the vertical asymptote. Right? So x equals 0 is the vertical asymptote. And sketch the graph of a function. All right, so maybe we should look at that. All right, so you have, let's see, we have to go back. All right, so we know that the first derivative is always negative. So this means that always. So original function y is always decreasing. Right, so it's always decreasing. So if you look at the picture, right, decreasing, decreasing, that looks good, and this is increasing, increasing, so that doesn't work. And this is increasing, increasing, decreasing, decreasing, so it's either those two. All right, then we know that the horizontal asymptote is what, at 1. All right, this guy has a horizontal asymptote at 1, but this guy has a horizontal asymptote that looks like some negative number. So we know that the answer is this guy. Okay, all right, so let's check the answer. All right, I came back. Actually, I made a mistake. So x-intercept, I have to put it as a point form. So it's I really need to put -9, comma 0. Right? Well, let's try that again. Sorry about that. Okay, came back, and I got the first one correct. And let's see, looks like everything is correct. All right, that's it. I hope that this was clear.